You've probably heard of the Northern Lights or the Aurora Borealis, and these is just a colorful, dazzling light display that goes on in the sky, and it usually happens only on the north and south poles of the Earth. But recently, in fact, this past weekend, starting Thursday, Friday, Saturday, and Sunday, this Aurora Borealis, or what we call Northern Lights, stretched all the way down south to Texas and Florida. That means that people all around the US and even around Europe could see these northern lights way far down south. So how do these northern lights come down to the south this far? And what role does the sun and maybe even geomagnetic storms have to do with it? Well, in this episode, I'm going to take you on a deep dive into the science of solar storms, auroras, and explaining what happened last weekend. And it is the May 2024 Aurora Borealis. Let's get right into this episode. Let's go. Now, before we start going into this episode, I just have to clarify one thing. The Northern Lights, also known as the Aurora Borealis, are these lights that happen above the equator, and usually it's in Alaska and Canada. And the Aurora Australis is what happens in the southern parts of the Earth, such as Australia and New Zealand. So those are two different types of auroras, but in this case, when I'm talking about the May 2024 event, both of these aurora circles were affected by this. That's because of the storms, the solar storms that we're going to get into later. So in this episode, I'm kind of focusing on the northern lights, but the same thing also happened in the south. So if you're listening from some southern area, this also applies to you because the solar storm was so widespread. Now, to take a closer look into how this all happened, we first have to take a deep dive into the science of auroras. Auroras are dazzling color displays in the night sky, and they're all caused by charged particles from the sun. You see, there are these things called coronal mass ejections, and this is when the sun releases solar flares into space, and these flares are basically large outbursts of energy that come from the sun. These are known as coronal mass ejections, and when this happens, the sun releases so much energy, and it basically travels as solar wind. The solar wind, as we like to call it, is made of charged particles, and it just flows through space until it comes across the Earth. You see, the Earth has two magnetic fields, the North and the South Pole, and this makes up this giant magnetic field. These two magnetic poles are not exactly the same as the geographical poles, but they are sort of in the same area. Earth has a magnetic field around it. So as these charged particles are coming towards it, and these charged particles, remember, this is called a solar storm or geomagnetic storm, and these particles come towards the Earth with lots of energy and lots of charged particles. Eventually what happens is that these particles start going towards the poles of the Earth. That's because they're attracted to the two poles of the Earth, and they're magnetic poles, so they're attracted to it. And what happens is that as these charged particles enter Earth's atmosphere, they start clashing with other molecules and gases like nitrogen, oxygen, and other things in the atmosphere of Earth. And when they start clashing with these charged particles start releasing light and energy. And these different colors that we see as auroras are all caused by the clashing of these molecules and these charged particles, which releases different colored lights. And that's what we see in the sky, and especially with the Aurora Borealis or the Northern Lights. The most important things that go into play are oxygen and nitrogen, and these two things, they're very abundant in the atmosphere. So when these things clash into it, they make different colors and different specific colors. Each gas or each thing in the atmosphere, when these charged particles hit it, they make a different color that we see as the auroras. So cool, right? Now, what role does this have to play in the solar storm that happened recently, and why are auroras so widely visible? Well, to get into that, it is very, very interesting. This happened because of a series of coronal mass ejections from a giant sunspot in the sun. Sunspots are basically these different areas in the sun that have different temperatures and different activity going on there. And this sunspot is so many times larger than Earth. And the solar flares and coronal mass ejections it releases are very, very powerful and impact Earth in a very, very big way. In fact, Friday, May 10th, is when all of this happened. When these coronal mass ejections hit Earth, and this May 10th event is very, very special because this is the first time a very, very strong geomagnetic storm has hit Earth since 2003. Well, that's a really, really long time, and it's all because of these geomagnetic storms. And what happened is that it's so powerful, this entire storm. It was actually rated a 5, which is on top of the scale for geomagnetic storms. It was a very, very severe geomagnetic storm. And these kinds of storms produce so many different charged particles and all that come from the sun, right? So this could affect satellites, communication, GPS, even power grids and communication systems. But luckily, people were prepared for that, and that didn't really happen this time. But it's still a very, very big thing. And since this happened on May 10th, these giant solar storms that hit Earth, they basically created these auroras that were a lot more powerful and a lot bigger. And that basically expand the sort of circle in which auroras are seen. So since the storm was so strong, these auroras were visible all the way down south to Florida and Georgia. In fact, I even tried looking at it, I think it was Saturday night. But unfortunately, I couldn't really see them. But it's still super cool to see all these other people that are sending in pictures. And it's just amazing to see that these auroras are being visible from even places that don't really get auroras. Usually auroras happen in Canada and Alaska, especially in the north. And in the south, it's usually Australia. But this solar storm was so powerful that it's able to release all these charged particles, and it's able to go into a wide range of people that are able to see it right in our backyards. Well, why is this happening all of a sudden? Well, it's because the sun has 11-year cycle, and this 11-year cycle is kind of the solar maximum and the solar minimum. So it's basically this cycle that the sun goes through that changes the amount of energy, amount of coronal mass ejections and solar flares the sun releases. And right now it's about in between the solar maximum and the solar minimum. So it's kind of near the point where most activity in the sun is going to happen. It's in the middle of that 11-year cycle. That's why we're able to see so many different events that are happening, especially with the sun at this time, because it's so active. It is so cool to think about auroras and the sun and how this is all happening even very recently and how this is affecting us on a daily basis. It's really cool to think about it. Did you see this aurora last weekend, and do you have any pictures of it? Well, if you do, please send them to us at spectacularsci.com/contact and email me at podcast@spectacularsci.com. I'd love to see your pictures, and maybe I will post them on my blog, so please do share them. That's podcast@spectacularsci.com, my email address. Thank you so much. Looking forward to seeing your pictures if you saw this aurora. Now, before we go, let's review what we learned in this episode. In this episode, we learned that auroras are caused by solar storms and solar wind, which is known as coronal mass ejections. As these powerful and charged particles are released from the sun, they enter Earth's atmosphere and start clumping around the magnetic poles. And when this happens, it starts clashing with other molecules that are in the atmosphere, causing all the colors we see in the sky. Now, why was this special event that happened on May 10th so visible to even people far down south like Florida and Georgia, and sometimes even Europe? And this also happened in the Southern Lights, or the Aurora Borealis, which is near Australia. How did this all happen? Well, it is because this solar storm was so powerful that came from the sun that was able to widespread these auroras, and all that energy was so much that it was able to make auroras visible to lots of other places, and like right in our backyards, especially in the US. It is so cool to think about all the science that's going around us. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science produced and hosted by me, Akshay Raman. Our theme song and additional music are by Charan Ramachandran. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a science question you want answered on a Spectacular Science episode and get a special shout out? Well, grab an adult and head over to spectacularsci.com/contact. There you can find a contact form. You can send me all your amazing science questions. Thank you so much. Also, don't forget to subscribe to this podcast wherever you're listening right now. It really encourages me, and you'll be up to date on all the new episodes. Subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science.